Okay, hello everyone. How are you? It's a pleasure to be here. My name is Omar Asensio. I'm an assistant professor in the School of Public Policy and one of the data science faculty affiliated with BBISS. And today I'm going to talk about electric vehicles. So I just wanted to just get a show of hands. How many of us have either driven an electric car or imagine ourselves driving an electric car? Okay, so let the record show there's an overwhelming show of hands by the audience. I think so. Thank you to Carrie for introducing the importance of transportation in sustainability and other issues. So I'll sort of skip that part of my talk. I wanted just to point out that at the latest forecast, so I'm sure usually when I talk about the importance of EVs and the adoption of EVs in society, I normally point to the Bloomberg New Energy Finance forecast, which their latest number is that by 2040, 54% of all cars will be electric on the road, and that's a fairly optimistic, fairly aggressive forecast. And over the last few months, we've been talking to various automakers, talked to General Motors and Ford, and talked to BMW, and they all let me know that their internal forecasts for EV sales are even more aggressive than that. So we see that, of course, the investment in public infrastructure for electric vehicles is happening in a big way, and I think there are numbers around $80 billion of new investment that's going to be going towards electrifying our fleets, particularly in the household sector. So with that said, I wanted to just highlight a couple of key findings from my research. So in my work, I look at the role of big data in public policy issues. And nowhere is big data more exciting than in the energy sector, where we're sort of transitioning from this antiquated analog system to a more digital system. So we're using data from mobile apps to understand how people make decisions and how to design incentives around the use of electricity. And of course, one of the major issues within the use of electricity for transportation is that we don't really separately meter energy consumption coming from cars. And so this presents us a tremendous challenge for us because if we design certain systems and incentives to deal with the congestion issues that we've heard about, for example, we really need a way to independently measure and not have to rely on surveys or simulations to understand how consumption is happening around. And so this presents a great challenge. And so what's happening now is that, like in many other cases, private digital platforms and private companies who are distributing their killer apps and people are using them are really controlling the majority of the important data sets that are going to be important for policy. And so, we've partnered with one of the killer apps for EVs, and we have something like, superpopulation of, 1.5 million, charging records and reviews and so forth. And so my team is using computational tools, artificial intelligence, to try to understand whether we can automatically detect failures in infrastructure. So there's a poster in the back from my team who have some really interesting results on doing that and showing the proof of concept. So let me just kind of close out by pointing out that for sustainability at Georgia Tech, we have a new project. This is joint with Emily Grubert in civil engineering and Sam Coogan in ECE. And we're going to basically have all of Georgia Tech's campus EV chargers, and we're going to be conducting a series of experiments where we'll be dynamically changing prices to understand how people use the electric vehicle charging, and then also using the mobile apps, the digital platforms, to have something called a wait list, and that's going to be a digital system that's going to represent a queue that we can use to manage the congestion problem. So what we're seeing in terms of behavioral strategies in EVs is that not only is it important to have the station work when you get there, so public charging is extremely important. There was a survey done by Accenture about 7,000 individuals in the U.S. and the ability to charge at work or in public spaces was overwhelmingly the top issue one of the top issues in the electric vehicle purchase decision. So a focus on the necessary complementarity of charging infrastructure is going to be increasingly important as we roll out the economics and the policy issues around vehicle electrification. So we're going to have this. So on campus, we'll have we'll be able to dynamically adjust price, or at least the transportation office has maybe they don't know yet. They've agreed to that, but we're going to be conducting a series of randomized controlled trials where we look at pricing as a way as one lever to understand and mitigate issues of charging congestion. And then secondly, we're going to be also activating a digital queuing system, if you will, for that people can reserve their charging spot in advance, and then essentially test the model for more efficient use of charging infrastructure. All of which we used digital platforms and mobile apps. All right. So I'm happy to take any questions, and of course, feel free if you have any questions about any of this. I'm happy to have a conversation, and of course, my team has a poster in the back. So thank you very much.